Hello everyone and welcome back to my channel. In this tutorial, we'll be diving into the exciting world of deep learning and exploring the power of neural network. We are going to build an artificial neural network using Tensorflow and Python with multiple neuron and fully connected layers. The dataset that we are going to use belong to a bank that is studying its customer to see whether they are going to leave or stay, and it contains around 10,000 observations. You will see that in this tutorial we are going to use the data preprocessing template that we created before on this channel, and we are going to use different set of tools as well. I would highly recommend for you guys to watch my previous tutorial about the artificial neural network on this channel. I'm going to use Google Colab, but you can choose any of your favorite IDE on this tutorial. To begin, in order to build an artificial neural network, we have to complete 4 phases: data preprocessing phase, building an artificial neural network phase, training an artificial neural network phase, making prediction and evaluating model phase. So whether you are a complete beginner or an experienced programmer looking to explore the world of deep learning, this video is perfect for you. By the end of this tutorial, you will have the necessary skills and knowledge to start building your own neural network using TensorFlow and Python. So without any further delay, let us get started. Welcome back everyone. Let us start with the dataset. In this tutorial, we are going to have an input vector containing a set of features, and we are going to predict the outcome, which will be a binary value. As you know, the artificial neural network can be used for regression or classification, and in this tutorial we are going to use it for classification. In the future, we are going to build another artificial neural network for regression. To download the dataset, please click the link in the description below. Let us first have a look at the dataset that we are going to use. As you can see, it looks like a real dataset. This is a dataset of a bank that collected some information about their customers. This information contains customer ID, which is the identification key for each customer, surname, credit score, geography, which means the country where the customer lives, gender, age, tenure, balance, which is the amount of money they have in their account, number of products they are using from the bank, such as credit card or car loan, has a credit card, which means whether or not the customer has a credit card, 1 mean has a credit card and 0 otherwise. Is active member, which means is the customer an active member using his account or the card, estimated salary, which is the salary of the customer estimated by the bank, and that is the last feature. Then the last column exited is a dependent variable, and it states yes or no, whether the customer stayed in the bank or left the bank. 1 means exited the bank and 0 means stayed in the bank. So what happened in reality is that the bank is monitoring their customer for a certain period of time, and they have collected all these outcomes that we saw in the dataset. The bank is trying to understand the correlation between all these features and the outcome, which is whether the customer will leave or stay in the bank. So we have to create a predictive model and train it on this dataset, and then we will deploy this model in a new customer that does not belong to this dataset. Then the bank will be able to anticipate when the customer will leave the bank, so that they can prepare an offer so that he or she will stay in the bank. So this model will be used to prevent the customer from leaving the bank and anticipate when they have the desire to leave the bank. In the actual implementation in this tutorial, you will see that we are going to build this predictive model, and we are going to train it on this dataset, and then we are going to deploy it in a new customer that does not belong to this dataset. And we are going also to predict if this customer will leave or stay in the bank. And not only this, using this predictive model, we are going to predict the probability of this customer leaving the bank. So we are going to start with the data preprocessing phase. Again, please check my previous video about data preprocessing step-by-step guide. which I left a link for it in the description of this video, because here we are going to go through it quickly. So, the first step in the data preprocessing phase is importing the libraries. And please note that TensorFlow 2.0 is already installed in Google Colab. The first step in data preprocessing phase is importing the dataset. In order to import the dataset, first you have to download the dataset from the link mentioned in the description of this video, and then using the browser in Google Colab to upload the dataset. I have already done so here. So let us now add the code to import the dataset. X here is the matrix of feature. It will contain all the columns except for the row number, customer ID, and sure name, as these columns are irrelevant to this dataset, and it will not help in predicting the outcome of the dependent variable. All the other features will be included because they must have an impact on the outcome, which means they might have an effect if each of the customers will stay in the bank or leave the bank. So we will take all the columns starting from credit score and except the last column up to the estimated salary. So we will keep the upper bound -1 in the range of column to skip the last column of the dataset. And for the lower bound, we will specify the index 3. This will create a relevant matrix of feature. And for the rows, we will take all the rows. That's why we specify here only a column. In the next line of code, we will take all the rows identified by colon and the last column of the dataset, which is exactly what we want for our dependent variable, and it is identified by -1. Let us print X and Y to verify the result. And it was successful. Now we will move to the encoding categorical data step. We notice from the dataset there are two categorical variables, which are geography and gender. So we will have to do some encoding work to encode these categorical data, either simple label encoding like 0 or 1 for the gender, or hot encoding for the geography column, in which there is no relation order between these variables. And also, please note that in this dataset there is no missing data. So we will do label encoding for the gender column, and the index of the gender in the data frame or matrix of feature X is 2. Since our matrix of feature contains the following column from credit score up to estimated salary, the gender column will have an index of 2. Let us add the code for label encoding the gender column. We took all the rows by specifying colon and only the third column by specifying 2. And to confirm this, let us print X. As we can see, we were able to label encode the gender column where the male is encoded into 1 and the female into 0. And now we will do hot encoding for the geography column, since there are no order relationship between the countries. We cannot encode France into 0, Germany into 1, and Spain into 3. We have to perform one hot encoding instead. The index of the geography column is the second column inside X, which means its index is 1. So let us add the code for the hot encoding for the geography column. Let us print x and have a look at the output. So we'll have print x. And indeed, the hot encoding is performed, and the dummy variable is moved to the first column of the matrix of the feature. In the result, France was encoded into 100, Spain into 001, and Germany into 010. Now we will move into splitting the dataset into the training set and test set. So let us add the code for it. Let us run now the code to make sure everything is working fine. And it was successful without any error. Finally, feature scaling is absolutely compulsory for deep learning. Whenever you build an artificial neural network, you have to apply feature scaling, and that's absolutely fundamental. We have to apply feature scaling to all of our features, regardless of whether they have already the values of 0 and 1 like the dummy variable, because it is so important to do it for deep learning. So the feature scaling here will be very simple. We will use the data preprocessing template that I mentioned before. So let us add the code now for feature scaling. Let us run the code and make sure everything is working fine. And it was successful. This will apply feature scaling to all the training set and the test set without specifying any indexes. And of course, our scalar object is only fitted to the training set to avoid information leakage. And by that, the data preprocessing phase is over. Next, we are going to build the artificial neural network. And please guys, for detailed information about this data preprocessing phase, please check my previous video about data preprocessing template. Now we will start with phase 2, which is building the artificial neural network. This phase is divided into 4 steps. The first step is initializing the artificial neural network. The second step will be adding the input layer and the first hidden layer. The third step is adding the second hidden layer. The fourth and final step is adding the output layer. So let us start building our artificial neural network. Back to Google Colab, we will start with the first step, which is initializing the artificial neural network. The first task we want to do is to create a variable that will be the artificial neural network itself, and it will be created as an object of a certain class. And the certain class is a sequentially class which allows us exactly to build an artificial neural network, but as a sequence of layers, as opposed to the computational graph. As we know, the artificial neural network is a sequence of layers, starting from the input layer, and then successfully we have the fully connected layer, up to the final output layer. And that is what we mean by the sequence of layer. A and N is an object of a sequential class, and the sequential class is taken from the models module from the Keras library, which belong to TensorFlow 2.0. We call first the TensorFlow as follows, from which we are going to call the Keras library, from which we are going to call the models module, and from this module we will call the sequential class. This will create the variable A and N, which represents the artificial neural network, which is created as an instance of the sequential class, which initialize our artificial neural network as a sequence of layers. Now we will start with the second step, which is adding the input layer and the first hidden layer. In this step, we are going to add the input layer and the first hidden layer. We are going to use the famous density class in TensorFlow. The way to add a fully connected layer in any phase of the artificial neural network is to use the density class. And the way to use it is very simple. By taking our A and N object, from which we are going to call one of the methods of the sequential class, and that method is add. We will call this method to add a layer, whether it is a hidden layer or a dropout layer, which allow preventing overfitting. Right now, what we want to add is a simple fully connected layer, and the way to add this is to enter in these parentheses that fully connected layer, which will be a new object or instance of a new class. So the fully connected layer we are going to build will be an instance of the density class, and therefore the only task we have to do is to call that density class, and this will create that fully connected layer object, and at the same time it will automatically add the input layer. The density class belongs to the TensorFlow library, then from which we are going to call the Keras library, and then we are going to call the module layers. This is the module that contains a set of different tools, and by tools I mean classes to add any layer we want in the artificial neural network. And then from this layer module we are going to call our density class. And the density class can take several arguments. And here for sure we have to add these arguments. And the most important argument is units, and the second one is the activation. The units variable corresponds to the number of hidden neurons we want to have in the first hidden layer. The input layer will automatically have all the features from the feature matrix. Each feature will be represented by a neuron in the input layer. But then when we create our first hidden layer, we will have some hidden neuron inside. And with this density class, we can specify how many hidden neurons we want to have. And now for the most famous question in artificial neural network. How many hidden layers do we usually want? Unfortunately, there is no rule of thumb. It is just based on experimentation. We will choose here 6. And you can try different values and do your own experiment. We will keep the default values for all the other variables except for the activation variable. As we saw in the previous videos about the artificial neural network, the activation function in a hidden layer of a fully connected neural network must be the rectifier activation function, and the code name for the rectifier function is relu. And that is all we need to enter here in order to create the input layer and the first hidden layer. Now I hope you know how to build a shallow neural network. Now we will start with the third step, which is adding the second hidden layer. The only thing that we have to do is to copy the code from the previous step. And that is what I mean. You can use add function at whatever stage to add a new layer and to create a deep neural network. So the way to add a second hidden layer is simply the same as adding a first hidden layer. Again, the number of units can be different from the first layer. You can change the value and you may get better accuracy by choosing a different number of units. Now we will start with the last step, which is adding the output layer. In this step, we have to do something different. But for sure, we want the output layer to be fully connected to the hidden layer, and that's why we are using the dense class. So for the unit, it should be 1, since we are dealing with a binary output 0 or 1. Then for the activation function, we don't want to have a rectifier activation function, but a sigmoid activation function. Because it will give us the probability also of the binary output. So it will not only give us the output of whether or not the customer will leave the bank, but it will also provide the probability for that output. And by that we are done. We have just finished creating an artificial neural network. Now we will start with phase 3, which is training the artificial neural network. In this phase we have 2 steps: compiling the artificial neural network and training the artificial neural network on the training set. We will start with the ANN object, which was created as an instance of a sequential class. And from this object, we will call a new method, which is the compile method, in order to compile the ANN. We have to enter 3 parameters into the compile method. The first parameter is the optimizer. The second is the loss function. And the third is the matrix. Because we can choose several matrices to evaluate the artificial neural network. For this example, we are going to choose one, and it will be the accuracy. For the optimizer value, it will be ADAM, which is the best one that can perform stochastic gradient descent. The stochastic gradient descent will update the weight in order to reduce the error in the prediction and the real result. In each iteration, we will compare the prediction to the actual real result. For the loss function, when we are doing binary classification, the value must always be binary cross entropy. And if we are not doing binary classification, for example, we are predicting 3 different categories, then we have to enter categorical cross entropy. And the activation function should be softmask instead of the sigmoid. For the third parameter, we can choose several matrices at the same time, which we will use to evaluate the artificial neural network during the training. In our case, we will choose the most used one, which is the accuracy. Now we will start with the training the artificial neural network on the training set. In this step, we will train the artificial neural network on the training set over a certain number of epochs. We will use the fit method to train our artificial neural network, which will take always the same parameter, x_train and y_train. When we are training an artificial neural network, we actually need to add 2 more parameters, which are the batch size, because it will perform better between the predicted value and the actual value. The classic value of the batch size usually chosen is 32, which is the default value. And the final parameter is the number of epochs. For this example, we'll choose 100. And please feel free to play with these numbers and choose different ones, as long as it is not too small, since the artificial neural network needs a certain amount of epochs in order to learn properly and find the correlation. And now we are ready to train the artificial neural network on 100 epochs. Please note the accuracy of the model and how it is evolving over the epoch. And we can see that it is actually increasing pretty fast. And the final accuracy we got on the training set is 0.8631, which means out of 100 observation, we have 86 correct prediction. And by this, guys, we created our first deep learning model. Next, we will start with the last phase, which is making the prediction and evaluating the model. Well done, everyone. We reached the final phase of building an artificial neural network. This phase is called making the prediction and evaluating the model. I'm not going to explain it here in details. I'm just going to show you how to use the predictive models that we built to evaluate whether this customer will stay or leave the bank. This customer lives in France, has a credit score of 600, he is male, 40 years old, 3 years tenure. The balance in his account is 60,000. He has 2 products. He has a credit card. He is an active member. His estimated salary is 50,000. So should we say goodbye to that customer? I'm going to run the code block here. I'm not going to explain it in this video. As I said, I'm going to create another video in the future just for this final phase. By running this code, we predicted that false, which means that this customer is staying in the bank. So that's it, everyone. This is how you build an artificial neural network, how you train it on the training set, and this is how you use the prediction model to evaluate whether future customer will leave or stay in the bank. I hope that this video helped you understand the basic of building an artificial neural network. Please don't forget to subscribe to my channel in order to get the latest update. Thank you for watching and see you in the next video.